Hello again. We are now on session 23, and that will be taught this week on Tuesday night, and these are the notes to go with it. You will notice on the first page and on the second page of the notes before we start that there are maps, and I want you to be able to see them. You can print these out in either black and white or color. I've made them that way. If you're able to print them out in color, I would suggest you do that because you'll be able to see more of the detail in the maps. And you may be able to even kind of click on them and enlarge them if you want to see it. We are in the 8th chapter of Luke, and we are at verse 22. And I'll not do a total introduction this week because I think we all know where we are. And we are going to see Jesus in a boat. We've probably seen Rembrandt's picture of Jesus stilling the storm, where there are two boats out there, one being rowed, the other with sails, and they're being swamped by these giant waves. And yet, when we look at pictures of the Sea of Galilee, we wonder, could you have that kind of storm on such a small lake? And the simple answer to the question is yes, very easily. And I'm going to explain that to you, both from a geological standpoint and from a meteorological standpoint, so you understand what's happened there, so you can appreciate it. Number one, I want you to look at the map on the first page. It's on the left side of the page, and it is a map showing the Middle East. It's showing part of Egypt, it's showing the Red Sea, it's showing the area where Saudi Arabia is today, and then at the other side of the Arabian Gulf, it's showing you what Iran looks like today. And so this is the area that we're going to be in. And what you should say when you look at the map is, Norm, I see words like plates, and then I see all these arrows going in different directions, and I see dotted lines. What does all that mean? The earth is a sphere. We know that. The crust of the earth is a series of plates, big plates that are anywhere from 30 to 120 miles thick. Now you say, man, that's a plate of rock that thick. Yes, but it's floating, if you will, on a layer of the earth called the asthenosphere. And that asthenosphere is hotter and it's more molten. It's not liquid, but it's kind of like Play-Doh, if you will, or silly putty, where you can mold it and you can movement. And so these plates that are riding on top of the mantle of the earth, on this thin layer, they are moving around the earth. And there are about 7 or 8 big plates, maybe 1 or 2 more, but then there are also 2 smaller plates. And as those plates move, they hit each other. And where they hit each other, straight on, mountain ranges build up, like the Himalayas, or the old Appalachian Mountains were made that way. Other times, one plate will go under another. Why will they do that? Because ocean plate under the ocean is heavier. Land plate is lighter, and so the land will stay up top as buoyant, and the ocean plate will go under. And where they go under, you'll see volcanoes like all along the Rocky Mountains, all up into Canada. Remember Mount St. Helens. And there are other plates that instead of going together, they move side by side, and they catch and they hold, and finally they break loose and move, and that's the San Andreas Fault. Now, why do I tell you that? Because the Middle East, the way God made the world, with these plates, the Middle East didn't always look the way it does. And the plates are moving. For example, on the left-hand side of the picture, if you look for the words Nubian shield, that's Africa, and you go north of it, upward, about an inch. You'll see the term Gulf of Suez, and then right above that you'll see an arrow kind of pointing a little bit west of north. That's telling you that that plate is moving in that direction. Say, how fast does it move? The Earth's plates move at about the same rate that your fingernail grows in a year. That means if you live in Galloway Township, this time next year you will have moved about 1.5 inches to the west. You say, Norm, that doesn't mean much. No, but when you start adding up hundreds of thousands of years, it can mean a lot of movement. Now, so you have that one plate moving kind of a little bit west of north. Now look at the Arabian plate right in the center of the picture. Look at the arrows there. Where this plate is going this way, this plate is going this way. Well, if this plate goes this way and this plate goes this way, look what just happened to my hands. They pull apart. Now, what do they do when they pull apart? They leave a valley. We call that a rift valley. It's been rifted. And what happens? Water from the sea pours into that. Well, that's how the Red Sea was created. That's how the Red Sea all the way up through the Dead Sea and the Jordan River Valley was created. We had the African plate, which, by the way, includes the Mediterranean Sea. Remember, that plate is 60 or 70 miles deep, thick. It moves away from the Mediterranean, from the Arabic plate, the Saudi Arabian plate, and the Jordan River rifts all the way up to a mountain. And by the way, that rift goes all the way down to this, under the ocean to the central part of Africa. And that's how we get our Jordan River Valley. Now remember, let's do it again. Here, let's do it this way. Here is sea level, right at the bottom. This plate goes this way, this plate goes this way, and all this drops down. So what drops down and becomes a